Question 25, which is question 8 on the higher tier paper. Here we're given a triangle ABC and a trapezium EFGH. All the measurements we're told are in centimetres and we're given them in terms of x. Okay, the different lengths being given to us in the diagrams. We're told that the perimeters of the shapes are the same. So the perimeters are the same, and then we're asked out to work out the area of the trapezium. So what you're going to need to do first of all is use the fact that the perimeters are equal to set up an equation and solve it to find x, where you put the perimeter of this shape equal to this one, rearrange and solve to find x. Once you've done that, you then need to use the fact that the area of a trapezium we can calculate with the following formula. So the area of a trapezium is 1/2 a plus b times by the height. So 1/2 times by a plus b times by the height. Now a plus b, if we draw out a trapezium here, that length there is a, this length here is b, and the height is the vertical height straight up, not the slanted height. With that information, have a go at the question and pause the video now. Okay, first of all, we're going to set up two equations. Now, using the fact we can see that these two sides are equal, that's what those two lines indicate, I've got 5x plus 5x plus 4x plus 8 is the perimeter for this triangle. If we add all of that together, I get 14x plus 8. If we do the same with the trapezium, I've got x minus 1 plus 5x plus 1 plus 7x minus 7 plus 5x plus 1. Again, we're going to simplify this down, and that comes to, well, we've got x plus 5x plus 7x plus 5x. That gives us 18x. And I've got minus 1 plus 1, which cancel out. Minus 7 plus 1 gives me minus 6. So I've got my two perimeters. I'm now going to put those equal to each other. As we are told in the question, the perimeters of these two shapes are equal. Once I've put them equal to each other, I'll rearrange to find x. So 14x plus 8 equals 18x minus 6. Now I want to move all my x's to the side that's already got the most so that x will stay positive. So I'm going to move these ones over to the other side. So I'll take 14x from here and take 14x from here. I'm taking away because on this side the 14x is positive. So if I rewrite this, I get 8 equals 4x minus 6. Now we've got a simple two-step equation. I'll take the minus 6 and add it, and I'll be left with 4x is equal to 14. Once I've got 4x equals to 14, I'm going to divide by 4, and we get x is equal to 3.5 centimetres. Okay, so I now know that x is 3.5 centimetres. What I now need to do is use that in this, substituting it into here, using the area of a trapezium formula, and calculating the area of that trapezium. So, just to show you the lengths, we've got A as the top here, which is x minus 1, which is 3.5, take away 1, which is 2.5 centimetres. B, we're told, is 7x minus 7, so that's 7 lots of 3.5, take away 7, which is, well, 7 lots of 3 is 21, 7 lots of a half is 3.5, that's 24.5 minus 7, which leaves you with 17.5 centimetres. H, we're told, is 4x, which is going to be 4 times by 3.5, which gives me 4 times 3 is 12, 4 times a half is 2, which together gives me 14 centimetres. So finally, if I plug those numbers into this formula, we do 1/2 times by 2.5 plus 17.5 times by 14, which is 1/2 times by 20 times by 14, which is 10 times by 14, which gives us 140 centimetres squared for the area of that trapezium.